Thank you, everyone. We are one of the last sessions on the agenda for this afternoon, and thank you for sticking around with us. I'm sure, based on the feedback we've gotten so far about integrity testing and low-level sump testing, this will be boring, fruitless, and not much going on. But no, seriously, I do expect a lot of participation, a lot of questions. So please hold your questions till the end of the session, and we'll go through them as time allows. We'll try to leave as much as we can at the end. So we're looking forward to your input. My name is Don Taylor. I'm the Environmental Fellow for the Tennessee Department of Environment and Conservation, Division of Underground Storage Tanks. I may be the only person in this room that I have what's known as a mountain accent. I may have sound more like Kevin Henderson than Kevin Henderson does. So if you need a translator, Kevin might be the best place to go. First of all, I'd like to introduce our first speaker this afternoon. He was just involved with the previous session here. Tony Raya is with the EPA Office of Underground Storage Tanks, the Director of Release Prevention. And without anything else, Tony, please come on up.
Hey, Sean. 180 minutes of sumps and testing. Okay. Yeah, life is good. Okay, so I'm going to be very brief, just outline the requirements from the federal perspective for sump testing and how this low-level testing came about. I know other panelists will get into way more history, but I'm just going to kind of talk about the recent history and how EPA developed a set of procedures. Alrighty. So, again, you all know this hopefully, but you got to test all containment sumps that are used for interstitial monitoring of piping at least once every 2 years. And you could do that per the manufacturer's instructions, requirements, per code of practice, RP 1200, or, and here's the key, requirements determined by the implementing agency to be no less protective of human health and the environment. And that's the provision that spawned the alternative low-level containment sump testing. So PMAA came to us about a year ago, and they basically presented us a scenario where there's a liquid sensor mounted at the lowest point, and can we do this low-level test? And we gave it some thought, talked to a lot of people, and we thought that, yes, that's good, a sensor, but we have to couple it with another requirement, and that's automatic shutoff. And so that package is, to us, EPA, no less protective of human health and the environment. So that was, we propped up a Q&A on that, and it was out there, and time went on, and, well, how do we actually do this test? That, that's kind of answered the broad question, but for Indian country, where we're the implementers, EPA is the implementers, we actually had to come up with procedures. Now, we're not really in the business, we're not, a nationally recognized body, we're not in the business of developing codes of practice, but we talked to a ton of people, and we developed a 6-page set of procedures for conducting the low-level test. It's been out there for a while. I haven't heard any negative feedback. We talked to many experts, and we think it's pretty good. Your state doesn't have to, if you are going to allow this low-level testing, you don't have to follow it to a T. We're not saying that. It's just basically a guide. We also developed, and it's all at this website, we also developed a document that you could show compliance. So it's like a checklist. And in a nutshell, I'm not going to go into a lot of details. I'll let the experts do that. But it's basically you're removing the debris, you're visually inspecting the sensor, you're doing a sensor test according to the manufacturer's instructions, then you're filling it up, the sump up 4 inches above the required height to activate the sensor, let the water sit for an hour, and if it doesn't drop more than 1/8 of an inch, you're good to go. Just a couple of reminders about addressing testing failures. We said this, not everyone might not agree with it, but if you're in a low-level testing scenario and there's damage to the sump, you only have to fix it up until above the about 4 inches above the activation of the sensor. So, some states are saying there's a repair needs to go. You need to be able to test it all the way to the top. So each implementing agency will have a different answer on that. For additional information, I've showed this in the last session, but keep pointing people to this technical compendium. States will use this when they're working out the kinks in their regs as they implement their regs. We're still, although we hope that this technical compendium kind of goes to a trickle, or there's not a lot more questions out there, we've answered most of them. We're still open to, we had a few questions last session, we're still open to adding Q's and A's to this to help work out the kinks from a federal perspective, make life easier on the state. So that's all I have. That's my contact info, and appreciate it.
Thank you, Tony. Thank you very much. Our next speaker in this session is Bruce Garrett. Bruce is the president of Dependable Petroleum Services in Plymouth, Massachusetts. Prior to his work with Dependable Petroleum Services, Bruce was an employee of Volta Oil Company, which I think was a family business. Is that correct? For 17 years. He's also a member of the Petroleum Marketers Association of America, and I'm going to get this wrong, so he's a member of the NEXIMA, which is the Northeast. I'll let you do that one. Northeast Convenience Store Association, and he's a member of their task force as well for tanks. Please welcome Bruce Garrett. Thank you.
There we are, right there. I can't chew gum and walk at the same time, so, I can't do this at the same time either. Well, let's try that again. Bear with me. Sorry about this. Oh, it is? Okay, it's just me here. Okay, perfect. Which button am I pushing?
Doing this right here.
Yep.
The first presentation there, previously, the first speaker closed it.
I think so, yeah. Yep. Good afternoon. Sorry about that. My name is Bruce Garrett. I'm with Dependable Petroleum Services and Volta Oil Company. We're a family operated business that operates out of Plymouth, Massachusetts. I started back in the mid-'80s when I got out of college. Started there by working as working in the service department, fixing pumps, putting tanks in, that kind of stuff, back in the good old days. And as we slowly developed, I spun my portion of the business off into its own company, which is Dependable Petroleum Service. I'm a member of NEXIMA, the New England Convenience Stores and Energy Marketers Association. There'll definitely be a quiz on that before you all leave. I'm a member of that. I'm also a member of PMAA. I'm on the OUST task force of both of those organizations. I was asked to come here today to talk about the origins of low-level sump testing. You're in for the story of your life. Here we go. First of all, NEXIMA, I don't mean to leave them out. That's our local organization, convenience store operators, petroleum industry people. That's our organization. We work on issues together. We work on regulatory things and that sort of thing. On the national level is PMAA, or the Petroleum Marketers Association of America. Basically, they represent companies like myself and other petroleum marketers. What do marketers care about? We want to invest in real estate to develop petroleum facilities. We want to protect our investment by protecting the environment and the real estate that we own. We want to invest in technology to help achieve compliance. And lastly, we want to get a return on our investment. So if we go above and beyond the regs and put in additional technology, we're hoping to get some relief, whether it be on inspections and things like that. A little later, I'll show you some slides where some of our groups tried to develop technology-based proposals that would be a little bit less inspection if you had more technology and that sort of thing. But back to low-level sump testing. Really what we're looking for is options. You know, we're looking for different ways to comply with the rules. All the facilities, in my opinion, every single one seems to be a little bit different. The sumps are a little bit different. The piping's a little bit different. The layouts are different. In my opinion, one approach doesn't work for every single facility. That's going to be a good time, getting into that sump to be able to block off the penetrations down 4.5 feet, you know? Those are very difficult sumps. You know, there's a dispenser sump. I know that when I talk to other contractors out there, it's very difficult to get new employees. Our demand is up with all these new regulations going out. It's hard enough to get employees. I'm trying to hire employees that are about this wide and have arms that are about 5 feet long. And unfortunately, I've been yet to find any of those guys. But sumps are different. You know, you've got larger dispensers, smaller dispensers. You got turbine sumps. You got dispenser sumps, transition sumps. You know, they're all different, you know. And so what are some of our concerns and challenges? The equipment that was installed maybe back in the, you know, mid-'80s, early '80s, late '80s, early '90s, I don't think they were necessarily installing it to be tested. I heard earlier today that a lot of test boots on secondary containment piping weren't installed at the time. I'd agree with that, you know. They really just didn't think about that. There's a lot of facilities that you can't quite get to the grommets to actually isolate that piping. When we installed it originally, we were installing it so that it was daisy-chained together. And so if you had a leak at the first one, it eventually would make it back to your turbine sump, and you could actually get it, you'd set off your sensor, know about it, and then investigate and resolve. Conduits, some of them aren't liquid tight. You know, we've got some issues with that. The large quantity of water that you have to use and the disposal costs. Some of the other folks have talked about those things. And then potentially removing dispensers from the island just so that you can access the equipment to isolate. You've got downtime. You know, and us petroleum marketers, we want fuel flowing out of the nozzles. You know, that's really what we're all about. We want to protect the environment, but we want to stay in business. And if we can't stay in business, we can't make money to be able to afford to pay for all of these things. It's kind of a circle. So, where did low-level sump testing start? I can tell you back in, I believe it was from about 2011 to about 2013-14, Massachusetts was writing new regulations. And our group, which I think started out as IOMA and ended up as NEXEMA, I won't bore you with that, but we worked with the Massachusetts Department of Environmental Protection. I heard I went to 2 seminars today or one yesterday, maybe one today, on working with government. And that's what we did. Our organization got together, we rolled up our sleeves, we met with the Mass DEP for actually a few years, sometimes meeting as frequently as once a month. And we tried to work through all of these issues. As I'm looking out into the audience, I'm seeing some of the folks that were involved in that. So hopefully I won't deviate too far and they'll call me out on something. But I'd like to say that we did a really good job. You know, did the industry get every single thing that they wanted? Of course not. Did Mass DEP get everything that they wanted? Probably not. But I think that we ended up with a great set of regulations that were technology-based. So if we installed more sensors, we could do less inspections. If we had a sump, we might not have to inspect our under dispenser or sump areas or turbine areas more than if we didn't have a sump. If we've got dirt or cinder blocks around our turbine sump, that should be inspected more than if I have a containment sump. If I have a containment sump that doesn't have leak detection, that should be inspected more often than a containment sump with leak detection. You know, that sort of thing. And that's really what we tried to do. And so one of the things that came up was sump testing. And you've heard all of the stories and the concerns and all of that kind of stuff. We were concerned too. The money that we thought we were going to have to spend and that sort of thing, it was going to be a big deal. In Massachusetts, we were required to go to secondary containment in 1989. So a lot of our secondary containment systems have been out there for a while. And again, a lot of them got installed, in my opinion, with no concept to be hydrostatically tested at all. So that's a big challenge for us. We worked our way through it, and I think what we ended up with was, I'd like to say, a fairly decent set of regulations that was, again, technology-based. And we ended up with low-level sump testing. And we said, you know what? We believe that having a sump sensor in a sump is better than having a sump with no sensor. And I don't think I can argue with that. I hear stories, and I appreciate that there are facilities out there that lift sensors off the bottom, and and bypass alarms and duct tape things and stuff like that. In my mind, that's an enforcement issue. That's not a regulatory issue. By changing regulations to prevent that, all you're doing is punishing the people that follow the rules. So I think we need to keep a mind on that. But we rolled out our regulations. I think they worked out fairly well, and that was the first time I had ever heard, seen, or thought about low-level sump testing. If somebody else had thought about it before that, then I'm wrong on origins, but I have a feeling that low-level sump testing started in Massachusetts. So word got out, and PMAA heard that I was talking about this type of thing and had some experience, and so they asked me to join the PMAA task force and said our first meeting is going to be in South Beach in February. Being from Massachusetts, I couldn't get my hand up fast enough. And so I went down there for the 3-day meeting and came back a couple of months later when it finally warmed up in Massachusetts. It was a great time. We sat down and we tried to further that same thought, and that is technology-based approach. And so we sat down and we talked about everything from sump inspections to, the walkthrough inspections to the sump testing, spill bucket testing, and all that kind of stuff. Unfortunately, our other meetings weren't in South Beach, so that wasn't so great for me. Then we went to the EPA. And that was the first time I had ever been to the EPA in Washington. It was a great experience. I really enjoyed it, other than the getting into the building part. And I don't know if it's because I was a petroleum marketer or if I was just anybody. But it seemed like, let's see, if I remember correctly, I think I had to bring my firstborn and leave them down at the first desk. I had to give them my social security number. I had to give them my serial number off of my computer. I had to go through a metal detector. I'm not sure if this was all just because I'm a petroleum marketer or if it was something else. But anyways, we got in, and I can tell you it was a great experience. I enjoyed talking to the folks from OUST. They were thoughtful. They listened to us. We had good dialogue going back and forth. We expressed what we thought our concerns were and where we thought our solutions were. We went back and forth. I think we talked, in person and offline a couple of times. And eventually they had said to us, yeah, we do think that this is equally protective of the environment, but we'd like to add these shutdown things, which I think makes some sense. So that's kind of how we went about it. We got to that. I think Tony talked about the specifics a little bit. I'm not going to get into that. I've got the same link on mine to get to the instructions. I think they did a great job with that. What are the pros? Well, I think if we can get more sensors out there and we can identify leaks quicker, we can protect the environment more. I think that we're going to invest in leak detection sensors, and we're going to get them out there. There's going to be less water that we're going to need to use and potentially dispose of, and it's also going to help us with reduced downtime. If I have to take a dispenser off every 3 years to block off that secondary because it's so deep, that's going to be a major problem for us. One of the things that we took a look at, talking about equally protective or not, and I've had a lot of conversations with a lot of people about low-level sump testing, and it seems like people either hate it or think it's okay. I don't see a lot of people with middle ground, it seems like, I don't know if it's the third rail or what's going on with it, but essentially, one of the things we did is we made some assumptions. We said if the average sump is about 200 gallons, and a mechanical leak detector does 3 gallons per hour. Essentially, if you look at these numbers, essentially, if you don't have any kind of sump sensor and you test to the top of your sump, that's great. It'll be tight and it'll hold there. But if you have no leak detection, it can keep leaking and leaking and leaking, and eventually it's going to come out of the top of the sump, Whereas if you potentially have a sensor in there, you're going to be notified when your alarm goes off, and you can go out and investigate it, hopefully when you only have a few inches of product in the bottom of the sump. And that's, I think, the idea. And then we also took a look at maybe electronic line leak detectors where you could have some positive shutdowns. So then if you had some leak detection. So again, we're looking for just different options to comply because, again, all of the facilities in our mind aren't exactly the same. Again, I talked about technology-based testing approach and that kind of stuff. So what we had talked about was, hey, you know what? Any new containment sump needs to be tested, and in my opinion, needs to be tested to the top. You know, you need to make sure it was installed correctly and you're good to go. If you've got an existing sump with no monitoring, you need to test to the top. If you've got existing containment sump with monitoring, you can do your low-level testing. And then, obviously, we thought if you invest in a double-wall sump and you monitor it, you should be able to get a break on that. You know, again, invest in technology and get rewards. Some of the incentive programs I heard about earlier, no-interest loans and deductible waivings, and that sounds fantastic to me. I'm also interested in if I invest my own money in additional technology, you know, give me some credit for that, you know? Don't treat me the exact same way as the guy with cinder blocks around his turbine. I guess that's our point. And then as far as inspections, the same kind of thing. You know, our thought is that if you don't have UDCs or turbine sumps, maybe it should be looked at a little bit more frequently. If you've got a turbine sump but no monitoring, maybe that needs to be looked at not as frequently as the dirt, but a little bit more frequently than if you have a sump and a sensor and that sort of thing. So again, it's really just kind of more technology you have, the better off, and options. Again, that's really what we're looking for. Options, 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 you know. So on sump testing, we've got vacuum, you've got full height, you got low level, you can do a double wall sump to comply. I'm hearing about fog testing now. I've heard about some other potential options that are out there. That sounds great to me. You know, as a marketer, I'm looking for the vendors to come up with new products that's going to help me save my piece of real estate, which is my investment. Thank you very much. I appreciate your time. That's the origin of low-level sump testing.
Thank you very much, Bruce. We appreciate you giving us both sides of the story and how this the new regulations would affect the marketers. It's always good to hear both perspectives. Now I'm going to welcome an infamous individual over here. Mr. John Olko is I knew him as a New Jersey bureau chief, but now he's the environmental compliance manager for Petroleum Marketing Group in Elizabethtown, Pennsylvania, and of course for 28 years prior. He's now retired from the state of New Jersey, and prior to that was, well, when I met him, he was the chair of the SWAMO OUST task force. So come on up, John, and I'd love to hear about some low-level sump testing.
Good afternoon. Oh, come on. We are all that stands between you and happy hour. Okay. First, I want to start off thanking the panel that's come up today to present this with me. The origins of this session started last fall at a SWAMO meeting, and Paul was there and Bruce was there, and I'm like, you know, we got a lot of talk and questions back then about low-level sump testing. And I approached these guys and said, hey, at the National Tanks Conference, would you be interested in joining me and putting together a session and presenting your views on this stuff? And they both agreed, and then the summer went on, and I was emailing them, and I didn't hear from Bruce. You know, I thought, well, maybe, you know, I got the wrong email, or maybe, you know, he's like, heck with that, I'm not getting involved in that. It turned out my email's going to his spam box, and, you know, but it all worked out, and Yeah.
Once you went to PMG?
There you go. But I do appreciate their time and effort in getting here, and of course Tony from EPA for lending their perspective on this whole thing. So I'm going to go through my slides here. Don, I lied earlier. I said I had 15 slides. Apparently I have 30. But I will be as brief as I possibly can. For those of you that know me, that's a big fat lie. So here we go. Low-level sump testing. What is it? That was my, first question when, PMA approached EPA, as was described. EPA came up with their policy. Well, the question was, well, what is it? And we got that question a lot from our regulated community and especially our contracting world. Well, what is it? What do you want us to do? So what then we did in New Jersey was we had to come up with a method. We had to put something together that people could use and follow and report back what their findings were. So we came up with the method of a low-level hydrostatic test for testing secondary containments. Most of it's based on RP 1200, which already exists, which gives a very good description of how to do a sump test, but this is a slightly different version of that same test. If you have not read it already, you should go and get yourself a copy of RP 1200 off the PEI website and, get it. They have a booth here. They could help you, locate how to do that, but it's a very valuable document. I know other sections in New Jersey's rule reference PEI documents, and it's a very nice way of saying to someone, that comes to us with, 50 different ideas, no, we're not. You got to follow what it says in PEI and give them a standard. So, now with every method, you have terms and conditions, and the New Jersey method has terms and conditions to be met in order to do the low-level sump test. One of those is you have to be positive. Okay? No, not your blood type. You have to have positive shutdown. So what we didn't want to put out there was you could go do a low-level sump test just because you have a sump sensor. We wanted you to have a sump sensor set up with positive shutdown. So only sumps with liquid sensors configured to shut down the STP would qualify for this testing option. We were not accepting a sensor that's just going to shut down a dispenser. We want it all shut down so that that owner and operator realizes he's got a potential problem he has to go deal with. Of course, there's always more terms and conditions. And now we get into the fun picture part, which makes this presentation go a little bit faster. Not much, but a little. Sumps must be free of debris and moisture prior to testing. And if you look at that sump there, there's a couple issues. Anyone see anything unusual there? There's a tire in that sump. And there's one more thing, and it might be a little bit harder to see. I wish I had a little bit more blown up picture, but if you look right about there, there's a piece of shiny duct tape on the flex line, okay? Not to mention whatever that is down there, water, fuel. So right away, that's not a good sump to go out and test right away. And of course, neither is this. It's full of, that one actually was probably more salt water than fresh water, and it actually passed the line test, but that's not, a contract opens that up, it's automatically rejected. One other thing we included was that the sensor activation must be done according to the sensor manufacturer's instructions for testing such sensors. So and I'm being exaggerating here, if the instructions were to take the sensor out of the sump and place it in a beaker full of fuel to see if it goes into alarm and shuts you down, those are the instructions you need to follow. So you need to follow those manufacturer's instructions for what the sump sensor manufacturer says they are. Now, that's what we have, or they in New Jersey have. I have to separate myself. So any one of those conditions are found, it's rejected. Another thing, the sump is found with liquid levels high enough to trigger a sensor that's already in there, but it's not found in the alarm. Who knows what's going on in that sump? This one, the water levels, at the sump sensor, was it an alarm? Is it doing anything? And there's a little bit closer picture of it. You can clearly see that should be doing something. The infamous sensor pulled up. I was in the session earlier, and Kevin Henderson brought this up, and I couldn't agree more with that point, because here's your sensor, but what's that? Is that properly positioned? Is that working? We've seen them, tied up on the side of the sump where they're never going to be picking up a leak. A visual inspection shall ensure the sump is free of cracks, holes, and compromised boots. This is right out of the RP. Okay? Positive shutdown. When liquid is detected at a sensor, it is unknown where the leak is, but the sensor must stop all possible sources. It's the safest way to ensure the issue is addressed. Again, functional testing is conducted by adding water to activate the sensor, triggering an audible alarm, shutting down the STP. And both the sensor and positive shutdown supplying the product line must be verified. So, how do they do that? How do you know that? You go to your friendly neighborhood Vita route, and you go into the back room, and you can go into the setup mode, and you can check the liquid sensor setup, and look there to see how the sensors are set up. Before I get to that, now, this is the tricky part. Someone could have set up for positive shutdown, have the sensors in the right position, have the programming all set, doing what they're supposed to do. It rains, they get some water in the sump, it shuts them down. They have someone come out, clean it out, pay a couple $100 to have that cleaned out, get their sumps back, the turbines back on, dispensers are back running, and they're having to do that every week because they just keep getting water in their sump. What happens when that happens? People get frustrated. And then what do? They figure out how to deprogram the Vita route so it doesn't do it anymore. Okay, and so that's something that also needs to be checked, especially you guys on the regulated side, you're going out to do your inspections. You can check that, or ask them, has their contractor checked it? Standard procedures are written in the document. Measure and record the water level at the sensor position at the start and end of an hour, and your pass or fail result. The New Jersey procedures, I'm not going to read all through this verbiage directly, but it's basically the same thing that's in RP 1200 until you get to, adding the water part, which you're not filling it up, you're just doing like number 2 says, add water to the sump until the sensor is activated and shuts off the submersible pump. The sensor then can be removed during the 1-hour test, allowing for the testing of other sumps and sensors. So you could take that, get the water in there, see if it works, then you're going to keep water in there for that hour, but then if you've got multiple sumps to test, you could go move on down the line. After completing that 1-hour test, document your test end time and water levels. Document any drop in water level. accurate to 1/16 of an inch. We put it on the New Jersey DEP test form, indicate pass or fail. Passing levels, drops less than an eighth, fail, greater. Here's what the results page look like. And this is all on the New Jersey DEP website, Underground Storage Tank Programs link. So you can go look at this for yourself and pull it up. And it's basically, contractor opens it up. Is the sump clean, dry, wet? Does it have fuel in it? Sump walls, good or cracked? Entry boots. Same for the UDCs. And then we get to the actual test results of the sensors, and there's your test times and results on the right-hand side. And there's my new contact information. And thank you very much for paying attention. And Pat, Don, you're up.
I said one of us was going to do it. You beat me to it. Let's see. And our final speaker for this afternoon is Mr. Paul Reber with Icon Containment Solutions. Paul is the Sales and Technology Manager for Icon. And let's see. I will let you have this. See if I can get you started here. Okay, there we go.
There you go. Thank you, Paul. Thank you. It's good to be here. Thank you. I come at this low-level testing issue from a little bit different angle. We're a manufacturer of sump leak repair applications, and we supply these applications to manufacturers all over the country and internationally. We're kind of uniquely and exclusively focused on this particular issue, and so we're interacting with people that are doing these tests, of course, before our applications, and then when the repairs are made after the applications. And so we have kind of different perspective on it, but our whole mission really is to supply and support EPA and agency compliant, effective, and lasting repair solutions. And when we talk about the EPA compliance, we're talking about the third-party testing, compatibility, and all the other things that have to be proven in that. But the whole point is to help a UST system owner and their service contractor be able to return that sump to a compliant compliant state in the most cost-effective way possible. And Bruce talked about that. Our options are to try to keep that okay. There we go. Just delayed. So our approach here is just to try to keep that business in business and still get them compliant. And they struggle with some of these things, obviously. Repairs are allowed, as you know, under EPA's requirements, as long as you meet certain criteria. And I think that that's really the important thing. Repair has evolved like equipment in the industry and recommended practices and all. And although there are still some things being done in the industry that are probably not very acceptable, there are practices that can be done properly that are lasting with the kind of materials that are going to last through the end life of the sump and not just from test to test. So really, three simple ways that you're having problems with the sump, right? It's either going to be structural, there's going to be some fitting degradation or other things going on in gaskets or seals, and then lids in terms of surface water. And all of that, of course, can be addressed depending on how severe the damage or the problems are. So in the in regards to what we do, all of the applications meet those criteria, and we're also working with industry and regulatory to develop an RP specific to that repair, which is missing in our industry right now. But, you know, sometimes we get asked the question, why repair it all? Why aren't we just forcing the owner to upgrade the equipment to proper workmanship and standards of equipment to today's standards? So, you know, which would require basically reconstruction for many of these small operators or major operators either way. And definitely that would make the manufacturers in the industry very happy. Equipment manufacturers would be selling a lot more equipment, but frankly, it just honestly comes down to the dollars. That's a very expensive proposition to put somebody out of commission for a very long time, and so the whole point is try to keep them in business and do these repairs within the existing structure as much as possible to keep them operating. Like I said, we have kind of a unique perspective on sump repair and testing. Sometimes that's a perspective you don't want to experience, but you know, frankly, I've seen more contortions of people in sumps in ways I just, you know, don't even like to think about it. It just gets a little bizarre sometimes. It can be done, but it's difficult work. And Bruce talked about, you know, the size of sumps. Well, you know, the size of the person in this business really does matter. And they, you know, they have to be able to climb in and do that work. Interestingly, they find them and they do it, and it's being done, you know, 1,000 sumps a year being repaired this way. So, not going to really go through some of the procedure and all of that completely. Just want to highlight a couple of things in terms of definitions. The containment sump for EPA is to be a liquid-tight container. And maintenance is to prevent, you know, a storage tank system, meaning the sumps as well, from releasing product. And repair means to restore it to that proper operating condition, right? So in the alternate low-level containment sump procedure, specific requirements that it is no less protective of human health and the environment, and you know, defining exactly how that should work with the positive automatic shutdown or shut off. So in these requirements, just want to run through a quick simple scenario that I think brings up some considerations that maybe with some tweaking or otherwise just considerations in how the states implement this program, you're going to get better results from what we've experienced in the industry. So here's a simple scenario: C-store operation, multiple sumps, several products running through each of the dispenser scenario, and oops, there's an alarm. Okay, the sensor in dispenser 5-6 is reflecting a leak. Now that may be discriminating, it may be non-discriminating, but there's a leak, you know, that they're going to address. Let's assume it's non-discriminating, and we don't know what it is. So according to the procedure, that dispenser should be shut off. And in fact, we heard John talk about in New Jersey, they're requiring now the STP, and frankly, that's kind of the direction that we think needs to be addressed in the procedure, because some states are really kind of limited or mandated that they can go no further in their own regulatory language than what EPA says. And so I think that in their language on this, they have given the latitude, frankly, for a state to modify this as necessary, and I know some states that I've talked to have done that. But so in this scenario, we don't know which product is actually leaking, and in fact, it could be in the line or it could be right there at the dispenser. We're not sure where that leak is. But remember this, the line is still pressurized. That dispenser may be turned off, but unless you shut the STP off, you've still got leak filling into that sump in a pressurized line, okay? Now, under the scenario that sump was only low-level tested, the integrity of the entire containment may be still in question, right? And so the only safe option in a scenario like that is to shut down all the STPs because you do not know which product it is. Now the entire site is shut down on a non-discriminatory sensor. It doesn't matter if you have sensors in every one of the sumps. It sends you into a situation where in a scenario like this, and this is just one of many, as Bruce talked about, there's a lot of different configurations. So it's just one of the complications that can come. But now the site's shut down. We don't know if it was just water or otherwise, but to be safe and to depressurize that line so that if there is a leak, we've stopped the leak until that can be figured out. The entire site is shut down in a scenario like that. And so that's definitely a consideration for a small business owner if they've elected for low-level testing, might put them in a situation where it's just not the advantage that they might have thought. If the correct pump is not shut off timely, again, and the integrity, because there's been no high-level or RP1200 level of testing, then in a scenario like that, you could potentially have a release, depending on the timeliness of how quick that STP can get shut down. And frankly, we've all been in sites where the alarms are going off and nothing's happening. I mean, who knows, what's going on. And I worry that the culture in those situations really isn't changing under that scenario, if that's but it may be an appropriate option for some sites. It just gets, it's one of those things you have to decide as a state regulator how you're going to manage all that. Here's the reality we see in the field and the feedback we get from testing companies. You've got 60 to 70% after a successful visual inspection. Because this is not walking over visual inspection, I see a boot's torn and they've looked in the sump and it appears to be leak tight. And now they're testing 60 to 70% failure in sumps. So that tells us that there's, on this first round of testing, which is a great thing, it's going to bring all stakeholders together and reduce risk for everybody involved. That just tells you that there's a lot of equipment that needs to be first corrected and certified before we start looking at things that bypass that. So here's just a few points to consider, and then we'll open it up for some discussion. But low-level testing places the reduction of the risk entirely on an electronic system. And, maybe that's good, maybe it's not. It's just something to consider. We've all seen these systems fail one way or another on the electronic side, or they get ignored. The current procedure, unless amended by the states, doesn't address the risk in the scenarios, at least that scenario that we just went through. And so you have to incorporate some language possibly, as New Jersey has, to address that, I believe. And our direct experience. Now, this is covering all segments of the market because we're all over the country, Canada, South America, but in the U.S. in particular. We support contractors that are servicing every segment of the market, your small business operator, the independent guys, and you're a little bit larger. We wish more of them were operating like Bruce. But we just run into the full range of things we see in this market. And this is a general statement, but it's just the reality of it, and that is that the independent group, those with the smaller number of sites, are investing less comparatively in their system for environmental compliance. And as a result of that, they're the higher risk category of UST owners in terms of these problems. And my guess is that they were largely part of the discussion that brought forward the revisions in CFR 40, Section 280, because it levels the playing field and it brings them to a point where they have to certify the integrity of their system on a larger basis than they had ever been required before, because the focus was always on those that were already trying to be compliant. So that's relevant because that's the group that's most likely to try to avoid the RP1200 type testing, which will be the full sump integrity testing. And so in some ways, as a result of that, the low-level testing is an option that does not change the culture again on that end of the market and not likely to check the behavior. I mean, we don't have a lot of bad actors, but there's enough of them in the industry that like to cheat the system, and it doesn't change that for them. In fact, it might actually give them more incentive, would be our thought on the matter, to float dispensers, you know, the mystery. We wonder how that happens. It just always seems to be above the level of the water in the sump, that sensor does. Or just ignoring alarms or playing the game for testing versus the actual application so that they're not shut down. If they're bad actors, they're going to cheat, and this gives them even more incentive because they do not want that site shut down. Okay, here we go. Yeah, another thing just to consider is that this particular testing method was proposed to PEI several times. They reviewed it for inclusion in RP 1200, and for various reasons, the committee, you know, determined that it really wasn't a best practice that they felt comfortable putting in RP 1200, and so hence the need for the lobbying and other things that occurred to try to get that. And we understand where that came from, and I think Bruce is on track in terms of options, and I think that, you know, that probably should be reviewed again. I think there's some things about this type of testing, low-level testing, that are good, and they provide advantages for an owner, but it just needs to be managed in a way that reduces the overall risk, which is one of the things that we feel like that it doesn't really minimize the risk in a way that EPA's requirements. It can't be no less, right, no less hazardous in that language than what you know, the other methods are. And I think that in some ways, until it's tweaked, that there is some of that risk. But so one of the other things to consider from the agency standpoint is, how do you enforce that now? I mean, in some respects, depending on how your state's set up, this could actually create more of a burden in terms of the enforcement and the tracking and all of that than the shifting of the burden that an RP 1200 testing requirement puts on the owner. The other thing is that there are, and really one of my last points here is that ultimately, to have all the additional sensors, make sure that they're properly designed and set up so that you have the positive shutdown you're looking for. The inspections that still need to occur, the sensor testing that has to occur annually, and the low-level testing that's still going to occur. And the only difference there is the volume of water, right? Except that we're bypassing the integrity testing of the actual sump. But given all that, I think it's really debatable whether or not there is the significant savings in the difference between the testing, because we're seeing in discussion, even in this conference, that there's a lot of efficiencies being found by the testing companies in how they're handling the water, in the methods that they're employing for the testing under even RP 1200. And so, you know, I think that the industry is responding, contractors are responding, costs always drive the market into a direction, and I think that the efficiency demand is there for the type of testing that's going to make maybe all of this kind of settle out in a way where it could be you know, neutral either way, and it more maybe just makes sense to give the testing option for the site based on the configuration that they have and the equipment they have, whatever makes the most sense. You know, the details and how that all gets managed at the state are obviously your problem. I would just simply say that the testing that is happening, we built our company around the proposed language, as I said, to give organizations an alternative to replacement, because this was obviously testing was going to uncover what EPA knew it would, and that was all of the system issues that are out there. And ultimately, that's going to lead to less risk for everybody, as mentioned. So thank you, and we appreciate it. We'll, I think, Tony or Bruce, we're going to, Don, that's his name, Don.
Thank you very much, Paul, and that will pretty much conclude our speakers' presentations. And we'd like to now accept some questions from the audience. If anybody has any questions they'd like to ask, we've got some moderators with mics. We can get you one. So, any questions from the group? Annette.
My opinion, based on the bad actors, is they can do that with high-level testing too, stringing the sensors up. So to me, that's not a reason not to go with low-level testing. I do not like the 1/8 of an inch and drawing the mark and waiting an hour. I much prefer the digital 0.001, 15-minute. I think it's much more accurate because I've seen service providers do it during the install testing. I'm just not buying the 1/8 of an inch with the thick magic marker. So Washington State will be writing a low-level testing, and I've been monitoring different states and just taking the best from each state. So thank you. This has been a really good presentation for states that are thinking of writing our own, and we'll probably send it out through Charles to ask for any comments before we finalize ours. So thank you.
Thank you, Annette. I'd also like to hear from any states that are taking what the policy the EPA has provided and is maybe adding something to it or making their own revisions as part of that for their specific state. Yes. Let's get you a microphone. We'll get you a microphone.
Hey, so my understanding, and I might have an incorrect understanding of this, is that the high-level, test for an SCP stuff is supposed to be 1 inch from the top of the sump. Is that correct? Like, isn't it supposed to be filled up with water to 1 inch?
The national standard, I think, is 4 inches above the highest penetration fitting.
Okay, so it's just above the, okay. Because I was kind of thinking that was a lot. But anyway, okay. That makes sense now what Annette was talking about, because I was just thinking that there was no way for a contractor to budget if it was just from 1 inch of the top of the sump. But okay. Never mind. Thank you.
Omar, back here in the back. Oh, okay.
Joe Godwin, New Mexico. We actually work with our petroleum marketers there in New Mexico. We put the low-level testing into our regulations, but we added conditions. And the first condition was that when the sumps are originally installed, it has to be a full test. And then they can do the low-level test next 3 times, but on the 12th year, it has to be a full test again. And also we put in there that if we do a compliance inspection and we find the sensor has been moved to the top of the sump, that triggers that the next test is going to be a full test.
Okay.
And we also put in there the caveat, if we ever find conditions at the site that indicate there may have been a release from the sump, then it triggers a full test as well.
So if the sensor's moved from the bottom, then that would require a full test from that point? Or?
Correct.
Okay.
One of my inspectors goes out there and does a compliance inspection. He opens up the STP sump. He finds the usual, we can pretty much guess what facilities it's going to be because we've been there a few times. It's hanging from the top of the sump again, and we're going to say your next one's going to be full.
Okay. Thank you.
Hi, a quick question. Great presentation, folks. I don't think I need an introduction. But this is a question related to the different configurations of sumps. As you all know, there's a lot of sumps that are designed to have a deeper base. Some of them are very shallow. I do agree that the positive shutoff may result in some releases if you have a catastrophic failure and the pump is shut off without the STP, and it does exceed the lowest penetration point. You could very well have a real release. But because there's technology available that will require that these sensors have a spring-loaded point, and I believe that technology
Position positive.
Yes, position positive. So that would prevent this whole elevating the sensors, which we've all seen are tied up and stringed up and taped up. But because of the different configurations of the sumps, is there some compromise between RP 1200 and what EPA is authorizing now that might be able to satisfy that, depending on what the depth of your first penetration is?
I will just say that any piece of technology, if someone wants to defeat it, they will. We've already seen a position positive sump sensor that's been taped closed. I mean, it's why pay for that technology? The technology can be used to improve your release prevention program, but you have to use it. And most people do. You know, in most 99% of cases, somebody's going to invest in that equipment, and they want it used properly. So whether they're the service people or the whoever's entering that sump and moving that equipment around, it's an enforcement issue from that standpoint in most instances. Anybody else? Omar, did you? I don't think I answered your question. Anybody, John, you want to comment on Omar's question?
Which part?
About that's a good question. Is it? Yeah, we'd like to count that. Maybe a SWAMO can do a head count and get, because I know in Region 4 in the southeast there are more that are allowing it than aren't. Is anyone in here from Florida? Does anyone know if Florida's allowing it? Georgia, I know is. Well, I don't want to go through every state, guys. Yeah, we'll do a survey. We'll try to get some feedback for everyone.
To clarify a little bit, Paul Reber, built a scenario on one of his slides that talks about where the potential failure could occur, and because you're not necessarily 100% sure where that failure is, especially if you have multiple product lines running through those dispensers, the only real way would be to try and shut down the STP sump. But because that's not an automatic, the dispenser is, you can still have just the volume of the line itself, given the pitch radius and what have you, that it's going to exhaust, and which would, in some cases, exceed the lowest penetration. But in a lot of sumps we've seen, they're designed a lot deeper, and the penetrations are a lot higher. In most scenarios, you won't have a volume of the pipe that's going to exceed the penetration. So given the fact that there's technology with these new low point sensors, and the fact that there's options in how you can design and install your sumps, there might be some go between what RP 1200 is requiring and what EPA is approving. And that's really hoping.
Sure, go ahead, Paul.
Well, as far as bridging the gap, as Tony mentioned when he started, EPA is not in the business of developing procedures, so we definitely don't want to be in the business of developing procedures. But what we wanted to provide was a example, since we put that this is a way of doing it that is no less protective of human health and the environment than the two that we spent years developing for the regulations, identifying that the manufacturer's requirements or a code of practice could be used. We came up with that suggestion. So we are definitely open to hearing any modifications to that, or any improvements. That would be great. I wanted to make one mention of the procedure that has been identified, especially with the shutoff of just the dispenser. It does require that an operator be in attendance if you use that option. and with all of those, you have to look at the individual. I think John called it the terms and conditions. You have to follow those terms and conditions in order to use those alternatives. So if you don't, categorically, you can't use those procedures. If you go there and the sensor's not where it's supposed to be, you don't have that operator there, you can't use that option. So it's, without even saying it, it's a no-go. You can't.
Regarding the previous comment too, that there are two things just talked about right here that were exactly what we were talking about in terms of EPA given the latitude to kind of define this a little closer so that you're reducing the risk, and that is, for example, certifying the sump, the entire sump on, with high-level testing, RP 1200 type testing on the front end, and then subsequent low-level testing is one option, obviously. Then at least that they're starting off on a basis that doesn't leave it exposed for potential release if there were one of those problems. The other, any adaptation you can make to that procedure that reduces the risk. From our experience, there's just an awful lot of leaking sumps. I mean, that 60 to 70% failure rate is a real number. It's not, just made up. That's an average coming out of the feedback from major testing companies that are going all across the country. And so it's kind of one of those things where that kind of needs to be addressed still. Now, California went through this. There's a precedent here where they experienced similar failure rates when they implemented the SB 989 program there. And in that first year, they had very similar failure rates. And then in the subsequent testing, 3 years later, that dropped significantly down like 10, 15%. And so, it just tells you that the system and the whole design of the changes for this testing was all about buttoning the system up and making sure we don't have these risks. And then, these other alternatives, as they're tweaked, definitely will be able to make it more livable for those that are trying to, afford or find different ways that conform best to their equipment configuration.
Any other questions or any other modifications states are making to the process that EPA carried out?
Chance to air your grievances about low-level sump testing, because I've been hearing about it all week, so...
It has been a hot potato, so...
What I would hear from my owners is, here's an option, and the big guys are like, we can't afford to be shut down, so we're going with the high level. That's the feedback I'm getting so far.
But what about the small ma and pa that doesn't mind being shut down? So, it's just an option, like you said.
I don't know, well, I think there are slight differences between the big guys and the mom and pops, but you know what? All the marketers are the same. They want that liquid coming out of the nozzle, and that's why I think when the dispenser gets shut down, it's key that you have to be in operation. Somebody's got to be there, because if they are, the very first thing they're going to do is get that pump going again, right? And if they have an issue, they've got to address it and fix so they can get the pump back going again, Yeah, and again, that's why we need options, because they're not all the same,
And Tim, you mentioned earlier that this was conditional on 24-hour fueling sites that may not have an attendant present in those after-hours times. That's a very common situation now in some parts of Tennessee. They'll configure the site to take a credit card 24 hours a day, and that site is not. In some instances, it may not be configured with any way to shut it down except with the emergency shut button. And some of those we've, along with the fire marshal, sometimes they kill the power to the whole site. Sometimes they just kill the power to the dispensers. I believe they're supposed to be required to shut down the submersible pumps and everything else separately. So those after-hours sites, may or may not qualify for that condition for low-level sump testing if they're not attended those 24 hours. Ray, I see you back there.
We had some folks join us via webinar, so just have one question here for the whole panel. So if I add new penetrations to the sump, does this trigger immediate sump testing and then therefore reset the 3-year cycle? In general, seeking feedback on the stringency of when a sump change forces another full test.
Sure.
I think the question was, you know, if you replace some grommets and stuff, do I need to test? And to the best of my knowledge, if you repair something, you need to test it after you repair to make sure that it's all right. So I would say yes, and whether it resets the 3-year calendar or not, I would have no idea. That would be a state by state.
Within 30 days, and then that should reset. Then you have to test again for 3 years.
So I guess the answer would be yes. It would be 3 years after that repair test was done.
Yeah.
And that brings up an issue of that would apply to that one repair. So now that you got to come back out in 2 years and test everything else at the site. So there's a calendar there that if you get into that, semantically you're talking keeping up with repairs for every different containment stuff on the facility when its test is due. So. Anyone else? Okay.
Sure. In Maine, we have a lot of safe suction systems. So I guess I'm grappling with where we do still allow single-wall piping on safe suction systems, so they don't have a piping sump at tank top. We do require dispenser sumps and sensors under those dispensers, however. So one, I guess I'm kind of grappling with if those dispensers would have to be tested for every 3 years, given that it's not part of the leak detection. And if it does have a tank top sump, would the positive shutdown be shutting off the dispenser?
With a suction system, since the pump is in the dispenser, you'd have to configure it that way. Now,
so every dispenser, yeah, going through that.
You could do that's a scenario where I see dispenser shutdown being workable, where you have a single product suction dispenser. You could assign individual shutdown dispensers. Right, I'm talking about safe suction.
So Maine in particular, we require dispenser sumps and sensors regardless of safe suction. So even safe suction systems require dispenser sumps and sensors. If it has single wall piping, it might not have a tank top sump, but it still requires a dispenser.
No, that's for existing and new systems. That's you guys have had the.
That's going forward. It's not retroactive on the systems, but that's been in place since 2004 in the state, I believe.
Okay.
Did you hear from the federal perspective? You have your answer.
Yeah. Yes, I do. I am clear. Thank you.
Raise that hand. Oh, back here.
I actually more have a question for the audience. It was brought up numerous times during the presentation that that's an enforcement issue. I was wondering what, especially for the sensors that have been pulled up, I was just curious about what states have done regarding enforcement for that and how they've done that.
I think I can speak to that uniquely for our state. In 2001, when the regulations, our first round of revisions after the 98 upgrade deadlines,